Delta Black Raider 330 is a next-generation unmanned aircraft built for long missions and tough environments. It's designed to give modern forces reliable eyes in the sky without needing a runway. Thanks to its hybrid electric system, the Raider 330 can take off and land vertically, or use extremely short spaces, making it perfect for remote or rough locations. This aircraft can stay in the air for more than 28 hours, travel over 1,600 nautical miles, and fly as high as 22,000 feet. That means it can watch large areas for long periods without needing frequent support. Its strong, modular design allows it to carry over 100 pounds of payload, including surveillance cameras, communication systems, and mission-specific equipment. The Raider 330 is built to work in challenging conditions, including GPS-denied or contested areas, where traditional systems struggle. Even though it's compact and more affordable, it delivers performance similar to larger Group 4 drones. By combining long endurance, heavy payload capacity, and flexible VTOL operations, the Delta Black Raider 330 sets a powerful new benchmark for tactical unmanned aerial missions. Kongsberg's advanced payload technologies are transforming unmanned surface vessels, USVs, into powerful, mission-ready platforms. By equipping autonomous boats with precise navigation, reliable positioning, hydroacoustic sensors, environmental monitoring tools, and smart data processing, these vessels can operate safely and efficiently without a human crew. With Kongsberg payloads, USVs can carry out a wide range of complex maritime tasks, from oceanographic research and seabed mapping to defense patrols and security operations. They provide real-time situational awareness and collect high-quality data, even in challenging environments. Platforms like the Kongsberg Sounder USV show how multiple sensor systems, long endurance, and adaptive mission capabilities come together. By combining intelligent payloads with autonomous control, Kongsberg takes USVs beyond simple navigation, turning them into versatile, high-performance tools. These innovations reduce operational risk, lower costs, and greatly expand what USVs can do, offering a glimpse into the future of smart, autonomous surface vessels for research, defense, and offshore work. L3 Harris Wolfpack is a next-generation military system that changes how modern missions are carried out. Instead of being just one weapon, Wolfpack is a smart family of connected vehicles that work together across air, land, and sea. These systems are designed to support precision attacks and electronic warfare in fast-changing battlefield conditions. The Wolfpack includes platforms like Red Wolf and Green Wolf, which can be launched from aircraft, ground launchers, or ships. This gives military commanders more flexibility and more ways to respond during complex operations. Red Wolf is built for long-range precision strikes against land and naval targets, while Green Wolf is focused on electronic warfare. It can detect enemy signals, disrupt systems, and send valuable information back in real time. What truly sets Wolfpack apart is teamwork. These vehicles can communicate with each other while in flight, adjust their roles, and take on new tasks as situations change. With modular payloads, the ability to scale production, and launch options across multiple domains, Wolfpack shows how intelligent, connected systems can deliver speed, adaptability, and smarter decision-making on modern battlefields. Leonardo Proteus is a next-generation unmanned helicopter built to change the way modern navies operate at sea. Unlike traditional helicopters, Proteus can fly and carry out missions without any pilot on board. It is being developed under the UK's Rotary Wing Unmanned Air System program and is based on a modified AW09 helicopter design. Weighing around 3 tons, Proteus can carry up to 1,000 kilograms of mission equipment. This includes anti-submarine sensors, sonar systems, radar, and cargo for supply missions. Thanks to its advanced AI-powered autonomy, the aircraft can manage complex flight tasks, understand its surroundings, and operate safely over long distances in harsh maritime environments. Built using digital engineering and lightweight composite materials, Proteus is designed for long-endurance missions over the ocean. It recently completed its first fully autonomous flight, proving that large unmanned helicopters are practical and reliable for real naval use. By using modular payloads and pilot-free operations, Proteus can perform surveillance, anti-submarine warfare, and logistics support while reducing risk to human crews. This innovative aircraft represents the future of smart naval aviation, offering stronger maritime security, greater flexibility, and more efficient naval operations.